Finally, we're going to look at a bunch of examples of the second type for finding the derivative f inverse. We start with our equation f inverse prime of a equals 1 over f prime f inverse of a. To use this formula for f inverse prime of a, notice that you don't actually need a formula for f inverse of x. If you have a specific value of a, you only need the value of f inverse at a and the value of f prime at f inverse of a in order to apply it. Consider the function f of x equals the square root of 4x plus 4. This is a familiar function, and suppose we want to find f inverse prime of 4. Using a equals 4 in the formula, we see that the formula says that f inverse prime of 4 equals 1 over f prime f inverse of 4. And this is a very important first step to solving this problem, is writing down this formula. Of course, we're going to work on the right-hand side, and the first thing to do is calculate f prime f inverse of 4 before we take the reciprocal, and we're going to work from the inside out. The first step here is to calculate f inverse of 4. That can sometimes be a long and complicated process, and you have to remember our method from before. We say f inverse of 4 equals b is the same as saying f of b is 4, which translates to saying that the square root of 4b plus 4 is 4. Now we need to solve for b in that equation, so we square both sides to get rid of that square root, and we get 4b plus 4 is 16, and finally that gives us that b is 3. So now we have f inverse of 4 equals 3. So that's our first step. We can substitute 3 for f inverse of 4 in our formula. Now we have f prime, f inverse of 4 is f prime of 3, and it's clear now that the next step is to find f prime of 3. Well, actually we can derive a formula for f prime here. It's not too difficult. We use the chain rule to differentiate. We've done this already in previous videos, and we get 2 over the square root of 4x plus 4. Plugging in x equals 3 there, we get f prime of 3 is 1/2. Back to our original formula, we're looking for f inverse prime of 4. It's 1 over f prime f inverse of 4. We've done all of the hard work. We have f prime f inverse of 4 is 1/2. So what we're looking for is 1 over 1/2, which is also known as 2. Here's another twist on that question. Suppose I'm looking for the equation of the tangent line to the graph of f inverse of x at x equals 4, and I'm given the formula for f of x. It's the square root of 4x plus 4. In order to do this, I first must write down the equation of the tangent line to the function f inverse of x at x equals 4. And that's y minus f inverse of 4, and that equals the slope, which is f inverse prime of 4 times x minus 4. We've already figured out that f inverse of 4 equals 3 and f inverse prime of 4 equals 2. So I can substitute these into the equation of the tangent to get y minus 3 equals 2 times x minus 4. If I tidy that up, I get y equals 2x minus 5. Here's another example, which is a little more complicated than the previous one. It's going to be the same method, but it's not going to be easy to find a formula for f inverse of 1. Let f of x equal the square root of x plus 1 plus tangent of x, and suppose I want to find f inverse prime of 1. Well, the first step in solving this problem is to write down our equation. F inverse prime of 1 is 1 over f prime f inverse of 1. So now, solving from the inside out on the right-hand side, our first step is to find f inverse of 1. Well, f inverse of 1 equals x is the same as saying that 1 equals f of x, or 1 equals the square root of x plus 1 plus tangent of x. It's very difficult to solve for x in this equation explicitly. However, we can use a little guesswork here. Recognizing that x equals 0 solves the equation tells us that our solution is x equals 0. So if we plug x equals 0 into the equation, we get 1 equals the square root of 0 plus 1 plus tangent of 0. And this actually fits the equation, so therefore x equals 0 is the unique value of x which solves the equation. F inverse of 1 is 0, and hence f prime of f inverse of 1 is f prime of 0. So now we have to find a number for f prime of 0, and in order to do that we have to calculate f prime. F prime of x I find by differentiating the formula for f of x. So I have 1 over the square root of x plus 1 plus secant squared of x is f prime of x, and therefore f prime of 0 is what I get when I plug in x equals 0 here. So it's 1 over the square root of 1 plus secant squared of 0, which is 1, and so f prime of 0 is 2. Therefore we have f inverse prime of 1 is now 1 over f prime f inverse of 1, which is 1 over f prime of 0, which is 1 over 2. So we've solved our problem. We have f inverse prime of 1 is 1 over 2. And you can see that this problem has many problems to solve within the problem. So it requires that we solve problems similar to problems we've solved before within the problem as we progress. Here's another variation of these types of problems where you're just given values of f inverse and f prime and f at particular numbers. So suppose this is all the information you're given. You have f of 10 is 21, f prime of 10 is 2, f inverse of 10 is 4.5, and f prime of 4.5 is 3, and you're asked to find f inverse prime of 10. Do you have enough information there to find the value of the derivative of f inverse at 10? Well, first step is to write down our formula for f inverse prime of 10. It's 1 over f prime of f inverse of 10. Then we fill things in from the inside out. So we start with f inverse of 10, and we actually have a value for this. So if we look at the information that we know that f inverse of 10 is 4.5. I can plug that in here in the brackets, and now f prime f inverse of 10 is f prime of 4.5. We actually also know what f prime 4.5 is here. We have that in our list of information. We're told that that is 3. F inverse prime of 10 is 1 over f prime f inverse of 10, which we see is 1 over 3. So although we're given a scant amount of information about f inverse, f prime, and f here, it's enough to solve this problem.